Betelgeuse is a red Goliath star. If you put it where the Sun is, it would expand out to the orbit of Jupiter, gigantic, entirely unstable, and destined to detonate. These blasts are among the greatest explosions of radio energy in the whole universe, creating more energy than a billion suns. Are you prepared for what is about to happen? Betelgeuse, a gigantic red supergiant star and one of the closest stars to Earth, has recently undergone a significant dimming. This event has captured attention and sparked speculation among astronomers and the general public about its potential implications. Some researchers believe this unusual behavior could be a precursor to a supernova, a catastrophic event that occurs when a star exhausts its nuclear fuel and collapses under its own weight, leading to a massive explosion. Such an event raises concerns not only within the scientific community but also among the public, as it prompts questions about its possible impact on our planet. Betelgeuse is a prominent feature in the constellation Orion, easily recognizable in the night sky due to its distinct shape and bright stars. Also referred to as Alpha Orionis, it holds the title of the brightest and largest star in this constellation. Recent data gathered by NASA's Hubble Space Telescope, along with observations from other observatories, have revealed that Betelgeuse experienced a significant mass ejection in 2009. This behavior is unprecedented for a star of its type and has piqued the interest of astronomers worldwide. While coronal mass ejections are common in our own sun, the unique event observed in Betelgeuse adds an intriguing layer to our understanding of stellar life cycles and the dynamics of massive stars. The distance to Betelgeuse remains a topic of debate among astronomers. Some estimates suggest it is farther away, while others indicate it may be as close as 724 light-years from Earth. Determining the exact distance of red supergiant stars like Betelgeuse is a complex challenge due to their immense size and variable characteristics. Betelgeuse stands out as one of the brightest stars visible in our night sky, boasting a luminosity hundreds of thousands of times greater than the Sun. However, this incredible brightness comes at a cost. The star is consuming its nuclear fuel at an accelerated rate, hastening the inevitable end of its stellar life. Eventually, Betelgeuse will deplete its fuel supply, leading to a dramatic collapse under its own gravitational force, possibly resulting in a supernova explosion that could give birth to either a neutron star or even a black hole, depending on the accuracy of current astrophysical models. This raises an important question. Does Betelgeuse pose a threat to Earth? If a supernova were to occur just a few hundred light-years from our planet, the consequences could be devastating. A supernova explosion can release an extraordinary amount of energy, potentially rivaling the brightness of an entire galaxy. Even if Betelgeuse is farther away, the effects of its supernova could still be significant and far-reaching. Amazingly, since the last recorded supernova in our own galaxy in 1604, humanity has yet to witness such an event up close. However, a notable supernova occurred in 1987 in the Large Magellanic Cloud, located 169,000 light-years away. While that explosion had significant effects, it posed no direct threat to Earth, serving instead as a reminder of the immense power and potential impact of cosmic events. The concept of a danger zone surrounding a typical supernova is fascinating and could have serious implications for life on Earth if one were to occur nearby. However, in the grand cosmic scale, nearby supernovae are relatively small events compared to gamma-ray bursts, GRBs, which are vastly more powerful and pose an entirely different level of threat. Supernovae can have devastating effects, capable of destroying biospheres and bombarding planets with lethal radiation. For example, a specific type of supernova can strip away a planet's ozone layer, leaving it vulnerable to intense cosmic radiation long after the explosion. This possibility was highlighted in a recent study that proposed new potential risks associated with massive stars ending their lives in spectacular fashion. When giant stars explode in a supernova, they can reach some of the highest luminosities known in the universe. In fact, the brightness of a single supernova can surpass the combined brightness of billions of stars. This raises the question, what would happen if Betelgeuse exploded? If a supernova were to occur, Scarab juice would become the second brightest object in our sky, after the Sun. Despite the vast distance separating it from us, the explosion would be so intense that scarab juice would shine brighter than a full moon, even during daylight hours. The sheer power of the blast would create shadows at night, illuminating the darkness in a way never seen before. Such a spectacle would be both awe-inspiring and terrifying, a stark reminder of the raw power of cosmic forces. While the visible light emitted by a supernova is undoubtedly spectacular, it represents only a fraction of the total energy released during such an event. Although high levels of visible light can pose risks, such as temporary blindness, the greater concern lies in the high-energy radiation produced alongside the visible light. This radiation, in the form of X-rays and gamma rays, could have severe consequences. One of the most significant dangers posed by this radiation is its ability to deplete the ozone layer, which protects Earth from harmful solar radiation. Without a strong ozone layer, life on Earth's surface would be exposed to extreme ultraviolet radiation from the Sun, potentially leading to mass extinction events. In the immediate aftermath of a supernova, various threats would emerge. In the first moments following the explosion, the intense radiation would pose an imminent danger. However, over time, cosmic rays, subatomic particles traveling at nearly the speed of light, would begin to penetrate the solar system. These cosmic rays could further damage the ozone layer and bombard Earth's surface with lethal radiation, compounding the dangers posed by the initial explosion. Additionally, cosmic rays carry a significant portion of the total energy released by a supernova, and their long-term effects can persist for millennia. Evidence suggests that such events may have impacted Earth in the past. For instance, elevated levels of iron-60, a radioactive isotope produced in supernovae, have been discovered in deep-sea sediments and lunar regolith. This finding indicates that Earth may have been affected by supernova ejecta within the past few million years. Astronomers previously concluded that there are currently no nearby supernova candidates that pose an immediate threat to life on Earth. However, ongoing research has uncovered additional potential risks associated with specific types of supernovae. Some of these supernovae can emit long-range lethal radiation, posing a greater threat to planets like our own. The mechanism behind this involves a dying star surrounded by a dense disk of material. When the supernova occurs, the explosion's shockwave strikes this disk, causing it to heat up dramatically. As a result, the disk generates an enormous amount of high-energy X-ray radiation, which can travel vast distances through space. These findings suggest that the cosmic habitable zone may be subject to additional constraints. Specifically, the outer regions of a galaxy, which contain fewer massive stars, might be safer for life than regions closer to the galactic core, where supernovae and gamma-ray bursts are more frequent. Understanding these threats is crucial for both astronomers and astrobiologists as they assess the conditions necessary for the long-term survival of life in the universe. While the probability of a nearby supernova or gamma-ray burst affecting Earth remains low, these cosmic phenomena serve as reminders of the dynamic and often violent nature of our universe. What would happen if scarab juice went supernova? If scarab juice were to explode, the immediate impact on Earth would depend on its precise distance from us. While the star is hundreds of light years away, a supernova of its magnitude would still be visible in daylight and could cast shadows at night. The most immediate effect would be a sudden burst of visible light and high-energy radiation. While the light itself would not pose a direct danger, the accompanying X-rays and gamma rays could damage Earth's atmosphere. If strong enough, this radiation could trigger ozone layer depletion, exposing the planet to harmful ultraviolet radiation from the Sun. Over time, cosmic rays, charged particles accelerated to near-light speeds, would begin arriving. These cosmic rays could have long-term effects, potentially disrupting the climate and biosphere. Some scientists speculate that past mass extinctions on Earth may have been triggered by nearby supernovae, though direct evidence remains limited. Will scarab juice explode soon? Despite recent dimming events, scarab juice is not expected to explode imminently. While it is nearing the end of its stellar life, predicting exactly when a star will go supernova is extremely difficult. It could happen tomorrow, or it could take another 100,000 years. Astronomers continue to monitor the star using space and ground-based telescopes, looking for signs of imminent collapse, such as increased neutrino emissions or further rapid dimming. If a supernova were to occur, it would provide a once-in-a-lifetime opportunity to study stellar death in real time. The explosion would be spectacular, creating a new nebula that could eventually give birth to new stars and planets. Conclusion: while the idea of scarab juice exploding is both fascinating and potentially alarming, current evidence suggests that it does not pose an immediate threat to Earth. However, studying stars like scarab juice helps scientists better understand the life cycles of massive stars and the risks they pose to planetary habitability. Whether in our lifetime or thousands of years from now, the inevitable supernova of scarab juice will be an event of cosmic proportions, one that will reshape our understanding of the universe and our place within it. The arrangement of actions to deliver the components important for the development of rocky planets is crucial. In the meantime, the inner regions, where stars form and die at a rapid speed, pose their own risks. Successive supernova blasts in these regions can ignite the surrounding space, increasing the dangers for any potential life that could exist there. New exploration shows that the inner boundary of the galactic habitable zone is likely located farther from the galactic center than previously suspected, reshaping our understanding of where life might actually flourish. So, what will the Betelgeuse supernova blast look like from Earth? While Earth's biosphere will likely remain unaffected, the scene itself will be impossible to ignore. According to experts, Betelgeuse will continue to shine brightly for more than 90 days following its explosion, reaching a radiance nearly half that of the Moon, though still multiple times fainter than a full moon. Essentially, it will appear as a brilliant point in the sky, serving as a beacon that could be visible even during the day. Its striking brilliance will captivate anyone who looks up, casting shadows at night. This cosmic event will undoubtedly be a source of fascination for everyone on Earth, as the supernova remains visible to the naked eye for months, gradually fading as scientists continue to study Betelgeuse. They are uncovering more about the life cycle of massive stars and the processes that lead to their explosive endings. Understanding these cosmic phenomena is crucial for gaining insights into the evolution of our galaxy and the formation of elements. During a supernova explosion, not only is light emitted, but an immense range of heavy elements, such as gold, silver, and uranium, are forged in the intense heat and pressure of the blast. This process, known as nucleosynthesis, plays a vital role in enriching the interstellar medium with the building blocks essential for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can become a stellar nursery where new stars are born from the dust and gas ejected during the explosion. This cyclical process highlights the interconnectedness of cosmic events and how the death of one star can lead to the birth of others. Experts have identified various supernova remnants that are still forming new stars billions of years after the original explosion, demonstrating the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Astronomers use Type Ia supernovae, explosions of white dwarf stars that reach a consistent peak brightness, as standard candles for measuring distances in the universe. This method has significantly contributed to our understanding of cosmic expansion and the discovery of dark energy, a mysterious force driving the acceleration of the universe's growth. Furthermore, the study of supernovae can offer insights into the potential habitability of exoplanets. Scientists are examining how the radiation produced during these stellar explosions could affect planets orbiting nearby stars, potentially altering their atmospheres and impacting the possibility of life. This research underscores the importance of understanding the environmental conditions that govern life across the cosmos. The possibility of witnessing a nearby supernova raises intriguing questions about societal responses to such astronomical events. Throughout history, supernovae have inspired myths, legends, and artistic expressions. The explosion of a star is not just a scientific phenomenon. It becomes a powerful symbol in human culture, representing transformation, destruction, and rebirth. In many cultures, the appearance of bright new stars in the night sky has been interpreted as an omen or a message from the universe. Moreover, advancements in technology have revolutionized our ability to detect and study supernovae. Space telescopes equipped with cutting-edge sensors can capture detailed images and spectra of these events, revealing their composition and behavior. Ground-based observatories also play a crucial role in monitoring transient events, allowing astronomers to respond quickly to observations and gather real-time data. The future of supernova research holds exciting possibilities. With new telescopes and instruments being developed, such as the James Webb Space Telescope, scientists will gain unprecedented insights into the life cycles of stars and the dynamics of their explosive deaths. These observations could lead to breakthroughs in our understanding of stellar evolution and the fundamental processes that shape our universe. In summary, the study of Betelgeuse and its impending supernova event serves as a gateway to broader discussions about stellar evolution, cosmic recycling, and the impact of these phenomena on life and culture. The exploration of such massive stars deepens our appreciation for the intricate and often violent processes that govern the universe, illuminating our place within this vast and ever-changing cosmos. Supernovae also play a crucial role in the cosmic timeline, marking the end of a star's life and the subsequent formation of diverse celestial structures. For example, the remnants left behind can evolve into nebulae, vast clouds of gas and dust that serve as fertile ground for new star formation. These regions can harbor complex chemistry, contributing to the emergence of organic molecules, which are the precursors to life. Additionally, the shock waves produced by supernova explosions can trigger star formation in nearby molecular clouds. This process, known as triggered star formation, highlights the interconnectedness of stellar phenomena and demonstrates how a single explosive event can ignite the birth of new stars and planetary systems. This underscores the significance of supernovae not just as endpoints, but also as catalysts for future cosmic evolution. In the grand scheme of the universe, supernovae also contribute to the dispersal of heavy elements throughout space. As these elements spread across the cosmos, they enrich the material from which future stars and planets are formed, ultimately influencing the chemical diversity essential for life. This cosmic recycling emphasizes the importance of understanding supernovae within the broader context of astronomy and the origins of the elements that make up our own planet, and by extension, life itself. The role of supernovae in cosmic evolution extends beyond the formation of new stars and planets. These massive explosions shape galaxies by influencing their structure and composition. The energy released in a supernova can drive powerful stellar winds and shock waves that disperse gas and dust across vast distances, regulating star formation and affecting the overall dynamics of the interstellar medium. This process helps prevent excessive star formation in some regions while triggering it in others, maintaining the delicate balance of galactic evolution. Moreover, the remnants of supernovae contribute to the enrichment of planetary systems, including our own. The presence of heavy elements on Earth, such as iron in our blood and gold in our jewelry, is a direct result of past supernova explosions. These elements, forged in the intense heat and pressure of stellar deaths, were scattered into space and later incorporated into the dust and gas clouds that formed our solar system. Understanding this cosmic connection highlights how life on Earth, and potentially elsewhere, owes its existence to the violent but essential process of stellar death and rebirth. Beyond their physical and chemical influence, supernovae also provide valuable tools for astronomers studying the universe. The study of supernova remnants, such as the Crab Nebula, has revealed crucial information about neutron stars and pulsars, dense remnants left behind after certain supernova explosions. These objects, with their extreme gravitational and magnetic fields, offer a unique laboratory for testing fundamental physics, including the behavior of matter under extreme conditions. Additionally, the detection of neutrinos and gravitational waves from supernovae presents new opportunities for understanding the fundamental forces of nature. Neutrinos, nearly massless subatomic particles, are released in vast quantities during a supernova, providing insight into the processes occurring in a star's core during collapse. The observation of gravitational waves, ripples in space-time caused by cataclysmic events, could further enhance our knowledge of stellar deaths, black hole formation, and the structure of space itself. As astronomers continue to refine their techniques for detecting and analyzing supernovae, the potential for groundbreaking discoveries increases. Future missions, such as advanced space observatories and next-generation telescopes, will allow scientists to observe supernovae in unprecedented detail, capturing the earliest moments of their explosions and mapping their impact on the cosmos. These efforts could lead to a deeper understanding of dark matter, dark energy, and the fundamental forces shaping our universe. The cultural and philosophical implications of supernovae are equally profound. Throughout history, humanity has gazed at the night sky in wonder, interpreting celestial events as omens, messages from the gods, or symbols of transformation. In modern times, our scientific understanding of these phenomena has not diminished their awe-inspiring nature, but has instead deepened our appreciation for the interconnectedness of all things. The death of a star millions of light years away can influence the formation of new worlds and even the emergence of life. A reminder that we are part of a vast, ever-changing universe. As we anticipate the eventual explosion of Betelgeuse and other nearby supernova candidates, we are witnessing not just a spectacular cosmic event, but also a moment that ties us to the grand story of the universe. From the formation of elements to the birth of new stars and planets, supernovae play a crucial role in shaping the cosmos and, ultimately, our own existence. Their study continues to push the boundaries of human knowledge, offering profound insights into the nature of life, death, and renewal on a universal scale. In the coming years, with advancing technology and growing curiosity, our understanding of these cosmic explosions will only expand, unveiling even more secrets about the universe we call home.